Studies indicate there is a chance that over $10 billion could be lost if this process goes wrong. Therefore, the telescope had to be very precise in its alignment with the space objects it aimed to observe. As part of the commissioning process, calibration targets had to be assessed, and the telescope's aiming and tracking systems had to be fine-tuned to ensure the instruments were focused on the correct targets. These measures ensured the JWST was functioning correctly and prepared to start its task of exploring the universe. All of these tests had to be meticulously performed. Scientists grew increasingly excited as these complex procedures went smoothly. Let's face it, even though we hope for smooth sailing, things don't always go as planned. It was truly remarkable that the JWST successfully completed all of these tests. More than 300 universities, groups, and businesses from 14 countries and 29 U.S. states contributed to the JWST project, making it a truly global effort. Then, in July 2022, the James Webb Space Telescope finally received approval to embark on its groundbreaking scientific mission. After passing all of NASA's tests, the agency confirmed that all 17 of the observatory's science instrument modes had been thoroughly vetted, and the JWST was ready to begin its journey of discovery. The JWST's primary purpose, like all telescopes, is to gather light and focus it to help us observe distant objects. However, what makes the JWST unique is its ability to observe a specific part of the electromagnetic spectrum, the infrared range, which is similar to heat. Our eyes can only perceive visible light, so think of the JWST as a highly advanced night vision security camera monitoring the universe. Its large size allows it to gather more light than other telescopes, enabling us to see smaller and more distant objects. Additionally, because it operates in space, it avoids the atmospheric interference that can obscure critical data. It's fitting that the JWST is called the eyes of the universe. The JWST achieves remarkable feats, and it all starts with its enormous 20-foot mirror, which concentrates on quite possibly north of $10 billion will be lost if this process turns out badly. Then the telescope must be extremely exact in its alignment with the space objects it needs to observe. As part of the commissioning process, calibration targets must be checked, and the telescope's pointing and tracking systems must be adjusted to ensure the instruments are focused on the correct objects. To ensure the JWST was working correctly and prepared to begin its mission of exploring the universe, these tests had to be conducted. Researchers were growing more and more excited as these complex procedures went smoothly. Let's face it, even though we all expect things to go well, they don't always go as planned. It was truly astonishing that the JWST performed so well on these tests. More than 300 universities, organizations, and companies from 14 countries and 29 U.S. states worked on the JWST project, making it a truly global effort. Then, in July 2022, the James Webb Space Telescope finally received the go-ahead to begin its amazing scientific mission after passing NASA's assessment tests. NASA stated that all 17 of the observatory's science instrument modes had been carefully examined and that the JWST was now ready to begin its journey of discovery. The JWST's primary job, like that of all telescopes, is to gather light and focus it so we can see distant objects. However, what makes the JWST unique is that it only observes a specific portion of the electromagnetic spectrum. The JWST operates in the infrared range, which is similar to heat, though our eyes can only see visible light. Think of it as an advanced surveillance camera with night vision that can watch the entire universe. The JWST is so large that it can gather much more light than other telescopes, allowing us to observe objects that are smaller and farther away. Plus, since it's in space, it doesn't have to contend with annoying interference from Earth's atmosphere, which can obscure important data. It's no wonder they call it the eyes of the universe. The JWST accomplishes many incredible feats. How does it do it? It all starts with its massive 20-foot mirror, which gathers light and sends it back to the spacecraft's instruments. When we talk about the instruments, the JWST has 4, each designed to collect a different type of light and give us a unique view of the universe. The near-infrared camera is the first in line. It's the main camera and will capture stunning images of galaxies, nebulae, and other amazing objects in space. Next comes the near-infrared spectrograph, which takes in light and breaks it down into its colors to provide more information about the objects it's observing. The mid-infrared instrument was built to study the early universe, exoplanets, and even our own solar system. Using infrared light, it can explore a vast range of objects. Finally, the fine guidance sensor / near-infrared imager and slitless spectrograph is used for precise pointing and can capture near-infrared light. They considered everything. You might be wondering why NASA chose infrared for the JWST when they have access to so many different wavelengths. There are longer wavelengths in infrared light than in visible light, which can reveal a wealth of information that would otherwise be hidden. Unfortunately, Earth's atmosphere blocks most of the infrared light from space, so we need a specialized camera like the JWST to see it. The bigger reason has to do with the expansion of the universe. Light coming from the farthest reaches of space shifts toward the red end of the spectrum as the universe expands. Observing the universe through this redshifted light is like traveling back in time, seeing the universe as it was in the beginning. It's like having a cosmic time machine that lets you look back at the early universe and see how things began. Everything is constantly moving away from us because the universe is expanding, and this movement causes objects to emit more red light. As objects move farther away, this redshift increases. Eventually, the light shifts so far that it enters the infrared range, allowing the JWST to explore the distant past of the universe. That's what the JWST does best. Its infrared sensitivity allows it to detect this highly redshifted light from objects billions of light years away. Thanks to its astonishing ability to peer deeply into the universe, the JWST can take us back in time. This isn't just a metaphor, it's actually how it works. It's like having a machine that can take us back in time. Light travels through space slowly, and the light from distant objects takes longer to reach us. So when the JWST looks at a faraway galaxy, it's not just capturing an image of what that galaxy looks like now, it's showing us what it looked like billions of years ago, when its light first began its journey through space. Scientists can use this valuable capability to study the early stages of the universe, when the first stars and galaxies were just starting to form. At the end of the day, the JWST shows us how the universe came to be the way it is today. NASA showcased the first scientific images from the JWST on July 12, 2022, in a live event that drew significant attention. These images included some truly breathtaking views of the universe, such as the stunning cosmic cliffs in the Carina Nebula and the ethereal Southern Ring Nebula. The JWST didn't just look at how these objects appeared, it also studied the atmosphere of the extremely hot gas giant exoplanet WASP 96b. It also gave us a view of Stephan's quintet, a group of galaxies in the midst of an interaction. Many people were thrilled and excited about these images, not only because they were beautiful, but also because they revealed important scientific facts. For instance, the JWST's view of Stephan's quintet unveiled new insights into how galaxies interact. The study of WASP 96b's atmosphere provided significant information about how exoplanets form and evolve. The very next day, on July 11, 2022, Joe Biden, Kamala Harris, and NASA Administrator Bill Nelson presented the first high-quality scientific image captured by the JWST. This incredible image, which shows the deepest infrared view of the universe ever seen, was created from just 12.5 hours of observations with one of the telescope's 4 instruments. What they achieved was impressive, but the work didn't stop there. In February 2022, NASA announced that the JWST had captured its first images of starlight. You won't believe it, but the images were a mosaic with 18 separate bright dots scattered in different directions. This picture showed a star called HD 8446. NASA's Associate Administrator for the Science Mission Directorate, Thomas Zurbuchen, tweeted that these 18 spots would gradually merge into a single star as the Webb telescope refined its position and focus. This was an exciting achievement that demonstrated the telescope's capabilities and its potential to assist future missions. Over the following weeks, the Webb telescope continued to make steady progress. Then, on February 18, NASA released a new and improved image of HD 8446, showing how skilled and precise the camera was becoming. The initial 18 unfocused copies of the star were intentionally arranged in a careful hexagonal pattern, offering a preview of what the final image would look like. After ensuring that each segment of the primary mirror was properly aligned, the observatory began the process of stacking the images. This aligned all 18 images on top of one another to create a single clear picture, giving scientists a more detailed view of the star. I should also add that Webb did something very special by taking a selfie with a special camera built into the near-infrared camera. This camera was originally made for engineering and alignment purposes. What a cool way to take a selfie in space. One of the mirror segments stood out in one picture because it was shining brighter than the others at that moment. This segment was the only one positioned correctly and focused on a star, although, over time, each mirror would be properly aligned. The area was likewise effectively arranged, showing how exact and precise the telescope is. They wasted no time. Once everything was set up, the telescope proceeded to make some significant discoveries, like getting a better look at the Falcon Cloud and tall pillars of gas and dust stretching into the universe. This was a major achievement for the JWST. We have always been astounded by the wonders of space. With its amazing visual capabilities, the Hubble Space Telescope gave us stunning views of heavenly structures, revealing their beauty. However, it couldn't penetrate the veil of mystery covering the complex processes occurring within these structures. This is where the James Webb Space Telescope comes in. It will fundamentally change the way we view space. In one of Webb's most recent images, the famous pillars of creation stand tall, showing a breathtaking scene of the universe's origins against a swirling, smoky backdrop. Many protostars appear as tiny red specks, each one evidence of the astounding forces at work in this stellar nursery. We now have a clearer idea of the incredible and transformative forces shaping the universe, thanks to this previously unseen view. Each of these colossal dust storms and gas clouds is larger than our entire solar system, forming the birthplaces of new stars. Derek Ward-Thompson, head of the School of Natural Sciences at the University of Central Lancashire in the UK, explains that the young stars seen in this image have not yet started burning hydrogen. As more materials accumulate, the process moves forward slowly, causing the core of the forming star to grow denser and more compacted. Suddenly, it reaches a density threshold that ignites hydrogen burning, with temperatures soaring to around 2 million degrees Celsius. The actual image is a marvel of engineering, created with a range of colors representing infrared bands that are otherwise invisible to the human eye. This technique allows us to see into the deepest parts of the cosmic scene, revealing a universe filled with complex processes and amazing phenomena. Connor Lenk, a research scientist at the Space Telescope Science Institute in Baltimore, was the mastermind behind assembling this image. He explained that what we see as blue in the image would actually look red in visible light. This fascinating shift occurs because as energy wavelengths lengthen, so do the associated colors. For example, the protostars in the red parts of the image emit light with a wavelength much longer than the human eye can detect. That said, this image is beautiful in more ways than one. Images like this not only showcase Webb's excellence as an infrared camera but also are immensely helpful for understanding how stars, including our own sun, form. Ward-Thompson made an excellent point when he noted that these photos help us understand how stars are born and evolve over time, providing valuable insights into this cosmic event. Fascinating as stars are to study, there was still a major mystery to solve: how to capture direct images of exoplanets. In the early 1990s, scientists made history by discovering the first exoplanets orbiting distant stars, achieved by observing how starlight dimmed slightly as a planet moved in front of it. The arrival of the James Webb Space Telescope revolutionized planetary observation, transforming how we study these distant worlds. With its highly sensitive instruments and the latest technology, like a coronagraph that can block out the bright light of a central star, Webb is able to directly capture images of exoplanets. Interestingly, Webb made history by taking the first direct image of an exoplanet less than a year after beginning its mission. The planet, named HIP 65426b, was first discovered in 2017. It is much farther from its star than Earth is from the Sun. Using two of Webb's cameras and various filters, scientists studied this massive gas giant. The resulting images were carefully assembled to create a composite picture, marking a huge leap forward in the exploration of distant worlds. This is a turning point not only for Webb but for astronomy in general. This world stands out for its enormous size. It is over 10 times the size of Jupiter, and its great distance from its host star, which were two key factors enabling Webb to capture this remarkable image, said Sasha Hindley, a renowned astronomer from the University of Exeter, who led these groundbreaking studies. This finding not only pushes the boundaries of what we know about exoplanets but also marks a major milestone in the history of cosmology. Today, direct imaging of exoplanets is more than just taking beautiful pictures. It is a critical endeavor aimed at understanding how planets form and what their atmospheres contain. This could potentially lead to the discovery of exoplanets with habitable conditions, a search that has been ongoing for decades. Until now, most research in this field has shown negative results, suggesting that finding a truly habitable planet is an incredibly challenging task. Yet, one of the most important and intriguing pursuits in science remains unraveling the mysteries of the universe and determining if life exists beyond our solar system. Thanks to the James Webb Telescope's ability to observe galaxies in detail, we are one step closer to finding an exoplanet that might be habitable. Webb stands at the forefront of that groundbreaking discovery if such a world exists, which would be a remarkable achievement. And hold on tight, there's more to come. Recently, scientists announced that Webb has observed the oldest galaxies known to humankind. These galaxies were formed when the universe was incredibly young, just 2% of its current age. The distance between us and these four galaxies is about 13.4 billion light-years, making them the farthest objects ever observed. The James Webb Telescope is providing us with new information about the beginning of the universe that we have never had before. It's hard to believe that the light from these galaxies began its journey 13.4 billion years ago and is only now reaching our telescopes. Webb's observations offer us a glimpse into their lives as they were billions of years ago, despite the unimaginable distance. The effort to study these ancient galaxies is enormous. Finding them alone was an enormous challenge for researchers. Since they were so distant, anyway, Webb's superb infrared abilities permitted it to get even the slightest signs coming from these distant, divine bodies. This astounding finding was made conceivable by this innovative expertise. As a vital piece of the JWST's progressed profound extragalactic study, analysts had the option to find and name these four extremely old worlds. Anyway, this initial step was just the beginning. The group needed to check out the information that Webb's near-infrared spectrograph had gathered to find out about how old they were. With this useful asset, they had the option to precisely measure these worlds' redshift. As we briefly discussed before, redshift is a significant measure of how much the frequencies of light that an object emits have changed because the universe is expanding. The farther away an object is from us, which implies it is older, the higher the redshift number. This vital technique for estimating confirmed our understanding of how exceptionally old these worlds are. The redshift value for these galaxies was an astounding 13.2, which is the highest value ever measured. These universes are certainly the oldest ever considered. Strong proof like this is truly hard to put into words. It is challenging to describe how significant this finding is. They formed seemingly forever before the primary stars were born in our own Milky Way galaxy. That being said, Webb has done the astonishing feat of capturing their images, giving us an intriguing look into the beginning stages of the universe. Something so monumental has been revealed that it could alter the way we consider the universe as we know it. Without a doubt, the James Webb Space Telescope's tremendous achievement is a recognition of the scientists and engineers who endeavored to build and operate it. Thanks to their insight and dedication, astonishing discoveries and breakthroughs have recently become possible. Specialists have been particularly intrigued by the possibility that the telescope might be capable of taking the clearest and most detailed image of city lights ever seen by humans. This might seem like a big task, but the circumstances are surprisingly favorable for achieving it. Consider this: Proxima Centauri, the star that is closest to our Sun, is a red dwarf located 4.25 light-years away. Astronomers have discovered Proxima b, a planet in this distant system that is in the star's habitable zone. It's thought to be tidally locked, meaning one side is always in daylight while the opposite side is always dark. This unique arrangement makes it possible to take an interesting picture like this. It's fascinating to imagine that there might be an advanced society on Proxima b that has intelligently covered the planet's daylight side with photovoltaic cells to generate power, which then lights and warms the night side. There are a lot of intriguing options in this hypothetical situation, and the James Webb Space Telescope could be vital in that scenario. In a recent scientific study, analysts showed that the telescope might be able to detect city lights on the mostly dark side of Proxima b. Webb's abilities could allow us to detect such signals, even if the artificial light was as faint as the light our society creates on Earth's night side. Currently, the artificial light source would need to remain in a frequency band that is around 100 times less than the spectrum of starlight for this to work. This potential discovery could have far-reaching impacts beyond what we can imagine. NASA's planned Large Ultraviolet Optical Infrared Surveyor and other future space telescopes will likely be even more sensitive, allowing them to detect even fainter artificial light on Proxima b's night side. The fact that city lights could be visible on a planet more than 4 light-years away is genuinely astonishing. It's a humbling reminder of how much we still have to learn and discover about the universe's vastness. There's no question that telescopes like the James Webb Space Telescope represent enormous strides in our exploration of the universe, but it's important to remember that learning is an ongoing process. There's always room for improvement and new ideas, so the quest for better telescopes will probably continue. The James Webb Space Telescope scope is a massive step forward, but it's only a part of our continued mission to figure out how our solar system and the worlds beyond work. One of the primary goals of the JWST is to look back into the early universe. The objective of this telescope is to understand how galaxies, stars, and planets came to be billions of years ago by examining distant worlds and their composition. JWST aims to gain a better understanding of where we come from in the universe. By examining the atmospheres of exoplanets, JWST acts as a cosmic detective, or perhaps a space spy, using a method known as transit spectroscopy. It observes a planet as it moves in front of its host star, and by studying how the star's light passes through the planet's atmosphere, scientists can learn valuable information about its composition, environment, and even whether it could support life. In a way, JWST is like a space archaeologist who uncovers the past of planetary systems. It's primarily focused on protoplanetary disks, which are like the cradles in space where planets are born. The telescope investigates these disks to learn more about how planets form, what they are made of, and the conditions that allow them to exist. On a different note, JWST excels at finding the things that make life possible. Its powerful spectroscopic tools are being used to search for molecules like methane, carbon dioxide, and water, essential for life as we know it. Finding them on distant worlds could significantly change how we search for places beyond Earth where people could potentially live. Large planets like Jupiter and Saturn have always been a mystery, hidden beneath their dense atmospheres. JWST will be able to change that. The telescope is designed to uncover their secrets, such as what the clouds are made of and whether there are any clues about how they formed and evolved over time. JWST isn't just focused on planets. It's also capturing detailed images of the regions where new stars are born. You can think of it as a cosmic camera taking breathtaking photos of stellar nurseries. These studies will help us learn more about the forces shaping the area around our galaxy. JWST also has a keen eye on incredibly massive black holes believed to reside at the centers of galaxies. Scientists are learning more about the conditions around these colossal objects, which are key to understanding how galaxies form and change over time. The James Webb Space Telescope is akin to a Swiss Army knife for space exploration. It's not solely focused on one thing, it investigates various aspects of space, from how planets form to how black holes operate. JWST will fundamentally alter our understanding of the cosmos in many ways, thanks to its advanced technology and capabilities. Let us know which of JWST's latest projects you want to learn more about. Thanks for watching, and to stay updated on all things space-related, follow us.